The Infrastructure Reality Check.
Quick note before we start. This podcast is AI generated. The hosts are fictional personas, and the episode is adapted from curated research articles and source material. So, Miles, we've been talking about AI infrastructure for a few episodes now. The compute cliff, the chip strategies, the model layer. This week felt like something shifted. NVIDIA put GPT 5.5 inches the hands of 10,000 of their own employees, live, at scale. That felt like a different kind of milestone than what we've been covering.
It does. And I think the distinction matters. We've been tracking promises and partnerships and roadmaps. This is a deployment. 10,000 people, every function, engineering, legal, finance, HR, running the same model every day on NVIDIA hardware. And the numbers they published around cost and throughput aren't projections. They're benchmarks from a running system.
Right. 35 times lower cost per million tokens, 50 times higher throughput per megawatt. Those are the kind of numbers that tell you something crossed a threshold.
And Jensen Huang sent a company-wide email calling it the age of AI. That's not nothing from a CEO who spent a decade building the hardware stack this moment depends on.
So let's start there. Why is this deployment different from the pilot programs and proofs of concept we've seen before?
Scale and economics. Earlier deployments were constrained, expensive, limited, wrapped in uncertainty about whether the math worked at enterprise volume. The GB200 NVL72 numbers NVIDIA published suggest the math now works. 35 times cost reduction is not marginal improvement. That's a different business case.
And the security architecture they built around it, cloud-based VMs, dedicated sandboxes, read-only permissions on production systems, zero data retention, that's not an afterthought. That's infrastructure thinking.
It is. And it tells you something about how NVIDIA, and by extension, any serious enterprise, is thinking about AI agents. You wrap them in auditability. You accept the flexibility trade-off because the auditability is worth more at that scale. That model is going to get copied.
The partnership between NVIDIA and OpenAI goes back a decade. Jensen delivered the first DGX-1 to OpenAI in 2016. But this deployment, the GB200 NVL72 cluster, the joint bring-up of a 100,000 GPU system that's a different depth of integration than a hardware sale.
It's co-engineering. OpenAI provides feedback that directly shapes NVIDIA's hardware roadmap. NVIDIA gets early access to new architectures. That's not vendor-customer. That's shared accountability for the defining AI systems of the next several years. And the GPTOS open-weight launch adds another layer. The same infrastructure economics that make Codex viable for NVIDIA's 10,000 employees apply to any organization running open-weight models on NVIDIA. Silicons. That's a much larger population than just Codex customers.
So what question does this deployment answer?
The whether question. Whether AI agents can operate at enterprise scale with acceptable economics. NVIDIA just answered that with a live deployment and published benchmarks. The remaining questions are human. Security boundaries, audit practices, whether organizational change management can keep pace with the technical capability.
That's the infrastructure reality check, isn't it? The silicon is ready. The question is what we build on top of it and how fast organizations can adapt.
Exactly.
Okay, so while that deployment was going live, Anthropic published something unusual, a postmortem on Claude code. 3 separate product bugs between March and April that degraded the coding agent. They reverted all 3 by April 20th. What happened?
3 changes, each reasonable on their own. Each shipped with internal testing that failed to catch the failure mode. First, they dropped the default reasoning effort from high to medium. faster responses, but users noticed the quality drop. By early April, they reverted it. Developers, it turns out, don't mind waiting for better output.
That's a meaningful data point about who pays for these tools.
It is. Paying subscribers are professional engineers with real deadlines. They notice, they complain. And when they do, the company either fixes it or loses them. Anthropic fixed it.
What's the second bug?
A caching problem in conversation history management. They wanted to optimize idle sessions, clear old thinking from the context, after an hour of inactivity to reduce latency and cost. Implementation had a bug. Instead of clearing once on idle timeout, it cleared on every subsequent turn. The model lost its reasoning trail. Responses became forgetful and repetitive. And because of cache misses, users' usage limits depleting faster than expected.
That one took more than a week to find and confirm. 2 unrelated experiments made it hard to reproduce.
Right. And the third, they added a verbosity constraint to Opus 4.7. Keep responses under 100 words unless detailed work requires more. After multiple weeks of internal testing with no regressions, they shipped it. It made the model 3% worse at coding. 3% is enough to notice. They reverted it April 20th.
The pattern isn't that Anthropic shipped bad changes. It's that 3 separate engineering teams, all using the company's standard QA pipeline unit tests, end-to-end tests, automated verification, dogfooding all missed failure modes that users found first.
That's the uncomfortable part. These aren't amateur mistakes. They reflect a genuine difficulty. AI products behave differently in production than in the lab, and the behavioral surface is wide enough that testing every corner is intractable. The fix Anthropic announced, requiring more internal staff to use the exact public build rather than an internal version, addresses one specific failure mode. It doesn't address the underlying problem.
Which is?
When you ship a system whose capabilities are non-deterministic and context-dependent, you will occasionally ship degradation that your evals don't catch. The model is not the product. The product is the entire system model, API, context management, prompt engineering, tooling, and the unpredictable interactions between them. Anthropic figured that out the hard way. Now everyone else has the postmortem.
And the competitive pressure is real. The AI coding agent market isn't a monopoly. If Claude Code degrades for a month and Cursor, Copilot, and the rest of the ecosystem don't, the migration happens quietly and permanently.
It does.
Okay. Let's shift to something that sounds like it belongs in the same conversation: quantum computing. There's been a lot of hype, a lot of promises, but this week, there was an analysis that tried to map quantum resource estimates to actual problem instances across 25 industries. What did it find?
Genuine advantage, but narrow. The math says quantum speedups are real for 5 sectors: pharma, chemicals, batteries, advanced materials, condensed matter physics. For 20 other industries where quantum companies actively market their solutions, logistics, financial modeling, machine learning, database search, the speedups are either quadratic, heuristic, or already matched classically.
Quadratic sounds like a lot until you account for what?
Classical computers parallelize those workloads at enormous scale, and error correction overhead for fault-tolerant quantum operations eats most of the speedup before you even start. Several previously proposed quantum advantages in finance have been dequantized, matched, or exceeded by classical algorithms developed after the quantum claim was published. This isn't a hardware problem waiting for better machines. It's a mathematical constraint baked into the speed-up formulas.
Where's the real advantage?
Wherever the underlying physics is quantum mechanical, You can't efficiently simulate quantum systems on classical hardware without hitting an exponential scaling wall. Quantum computers don't face that wall for these problems. The Phi-MoCo problem simulating the active site of the nitrogenase enzyme for fertilizer production is maybe the strongest economic case. Resource estimates have dropped 5 orders of magnitude in 8 years. Hardware timeline, 2031 to 2036.
Battery technology appears even more tractable.
Less than 500 logical qubits for next-generation cathode design. The market is large. The quantum application targets exactly the problem class where classical methods are least reliable. Hardware timeline, 2029 to 2032.
And the error correction revolution is compressing overhead faster than hardware is scaling out. A problem that required 1 million physical qubits 3 years ago may now require 10,000.
That compression, not raw qubit count, is the metric that matters. And it's improving at a rate that makes 2030's hardware timelines more credible than they appeared 5 years ago.
So, what's the strategic hazard for companies and governments deploying quantum computing teams and acquisition budgets?
Most of them will get nothing useful by the mid-2030s. The organizations that concentrate resources on the 5 genuine winners, pharma, chemicals, advanced materials, and begin building quantum simulation capability now, will hold structural advantages when 10,000 plus logical qubit machines arrive. Everyone else is following marketing, not math.
Okay. So that analysis is about quantum computing's computational advantage. But this week also brought news about quantum networking, a different problem. Cisco announced something called the Universal Quantum Switch. What is it?
A room temperature device that routes entangled photons without destroying their quantum state using standard telecom fiber. It's a switching architecture for quantum networks, the thing that enables distributed quantum computing instead of just point-to-point links.
Why does that matter?
Scale. Fully connecting a 1,000-node quantum data center point-to-point requires roughly 500,000 direct fiber links. A switching layer makes that tractable. Without it, quantum computing hits a plumbing problem long before it hits a qubit count problem.
The room temperature constraint is the real story here.
Most quantum experiments operate near absolute zero. Maintaining those temperatures across a network is substantial and non-trivial. Cisco's switch operates at room temperature and uses standard telecom frequencies on existing fiber infrastructure, the same fiber that already connects data centers globally. That means quantum networking can leverage deployed infrastructure without specialized builds. The timeline shifts from theoretical in a decade to potentially tractable in the near term.
And insertion loss signal degradation through the switch was less than 4% in validation experiments. That's the number that tells you it preserves quantum information.
It is. And the modality conversion is also worth noting. Different quantum systems encode information differently. Polarization, time bin, frequency bin, path encoding. Current systems largely can't talk to each other because of incompatible communication formats. Cisco's switch translates between modalities at input and output. A neutral atom QPU can communicate with a trapped ion QPU through the same infrastructure. That means quantum networks built with a switch aren't locked to a single hardware vendor or architecture.
And Cisco is already demonstrating near-term applications that don't require fault-tolerant quantum computing. Quantum Alert, entangled photon pairs for fiber optic security, where any eavesdropping attempt collapses the entanglement and triggers detection based on physics rather than software. Quantum sync correlated decision-making across geographically distributed locations, bypassing classical speed-of-light constraints.
Those are deployable now. The hybrid quantum classical network isn't speculative architecture, it's what's available now. And that's the point. Cisco isn't positioning this as a qubit play, it's a network play. And in the transition from quantum experimentation to quantum infrastructure, network architecture is where the strategic leverage is likely to accumulate.
So let me ask you something about this whole picture. We've got enterprise AI deployment at scale, NVIDIA and OpenAI, real economics, real auditability. We've got quantum advantage that's real but narrow 5 winners, 20 industries where the marketing exceeds the math. We've got quantum networking getting its infrastructure layer built out. What does this add up to?
A reality check on the infrastructure underneath AI. The model layer got all the attention for years. The compute substrate, the networking, the systems that actually run these things at scale, that's where the durable strategic positions are being established now. And the patterns we're seeing across these stories are consistent. The technical capability is advancing faster than the organizational and security frameworks that need to sit on top of it.
That's a thread.
It is. And it connects to something that might seem like it's from a different conversation, but I think belongs here. There's been research tracking how much people actually speak to each other out loud each day. A meta-analysis from 2016, so it's a decade old now, found verbal speech declined about 28% between 2005 and 2019. From roughly 16,600 words per day to under 12,000. And if that trend continued through the pandemic and into the AI era, we're possibly below 10,000 now.
That sounds like a different show, Miles.
Maybe. But consider what AI agents are architecturally designed to do. They conduct phone calls. They write messages. They draft social posts. They handle customer service. Every interface improvement in AI reduces the need for human speech. And if the research is right, and I know the methodology has limitations, the population that's losing words fastest is people under 25. The cohort that should be in peak verbal development is the most speech deprived.
You think that's connected to the AI infrastructure story?
I think the infrastructure story isn't only about what the machines can do. It's about what humans stop doing as a result. And if the substrate of human communication's spoken language, the practice of negotiating disagreement, the signaling of vulnerability is eroding. At the same time, we're building AI systems that handle more and more of our coordination. That's worth noting. Not as a panic, but as a structural tension that the infrastructure story contains.
Okay, hold that thought. Let's talk about something that feels more obviously like a corporate story. Tesla's Q1 earnings. $22.4 billion in revenue, $477 million in net income. Solid growth. But you said the earnings release was essentially a mission statement for a company in active transformation.
It was. Tesla missed the consensus estimate by about $240 million, modest miss. But the trajectory matters more than the headline. What's in the earnings document is a sentence that got almost no attention. The first-generation Optimus line, designed for 1 million robots a year, will replace the Model S and Model X lines in Fremont. Gigafactory Texas is getting a second-generation Optimus line designed for 10 million robots annually.
The Model S and X have already been discontinued to make room.
They have. The Cybercab has been spotted on public roads with a steering wheel still installed. The robotaxi service launched in Dallas and Houston was, by most accounts, largely non-functional due to insufficient vehicle supply. None of that reads like a company protecting its core automotive franchise.
What are the numbers telling us?
Revenue still comes overwhelmingly from car sales. That hasn't changed. What has changed is the capital allocation and factory floor decisions Tesla is making right now, which telegraph where the revenue base will come from in 5 to 7 years. And Tesla is also developing a new, more affordable electric SUV, a program it canceled 2 years ago, according to Reuters. If that's real, Tesla would be running 2 distinct product cycles simultaneously: a human-driving consumer EV and a humanoid robot line. That's an extraordinarily complex manufacturing bet for a company that has repeatedly struggled with production ramp timelines.
What's your read on the timeline risk?
Tesla hasn't published a detailed Optimus production timeline, cost per unit, or pricing framework. The million-unit design target is a design target, not a validated production forecast. Gigafactory Texas's second-generation line is still being designed. The gap between design capacity and realized output at Tesla has historically been measured in years, not quarters. The robotaxi service launched with vehicles that were, by multiple accounts, largely not available to passengers. That's a proof of concept, not a commercial business.
But the direction is clear.
The direction is clear. Tesla is dismantling the product line that made it a trillion-dollar company in order to prove it can be a robotics company. The earnings report is a snapshot of a business in active transformation, revenue still growing, profits still positive, but the capital being deployed tells a different story than the headlines.
So let me bring it back to where we started. We opened with NVIDIA's 10,000-person deployment as a defining moment for enterprise AI. You've now walked through quantum advantage, that's real but narrow, quantum networking, getting its infrastructure layer, a study showing human speech in decline, and Tesla dismantling its car business to build robots. What's the through line?
The infrastructure reality check. Across all of these stories, enterprise AI deployment, quantum computing, quantum networking, even the speech decline, the common thread is that the technical capability is advancing faster than the human and organizational frameworks that need to develop alongside it. NVIDIA's deployment answered the silicon question. The questions that remain are human: security boundaries, audit practices, change management. Quantum advantage is real, but only in 5 sectors. The organizational and strategic clarity to focus on those 5 is the harder problem. Cisco's switch makes quantum networking tractable, but the hybrid quantum classical network only delivers value if organizations know how to build for it. Tesla's transition is underway, but the manufacturing execution risk is real and the timeline is not published. And the speech decline, whether you see it as crisis or trend, is the ambient human context in which all of this infrastructure is being deployed.
That's the episode.
I think so.
Okay, that's our time. See you next week.
See you next week.